job schedule or question, it is better to reword it into something that makes more sense. Here's what I think makes more sense. Given an array, cut it into decontiguous subarrays and return the minimum sum of max of each subarray. With the example given, 654321 with D2, what we have to do is cut it at some spot and create two subarrays where the maximum of each one adds up to the minimum value possible. In this case, if you have this array and this many days, it only makes sense to cut it between 2 and 1 because that would give you a 6 max here and a 1 max here for an answer of 7. If you were to cut it here, it would give you a 6 max here, 2 max here, and the answer would be 8, which is not optimal. The way to solve this question is use dynamic programming. What we want to do is try every single cut in every single space. So you can imagine if I have, something like this and my D is equal to 4, I have to cut in 4 different locations or 3 different locations to create 4 subarrays. And I have to try every single possible possible cut, and check if that's the optimal result or not. I will store my results in a matrix such as this one. The sizes of it will be D+1 and by job difficulty.length. The reason it's D+1 is because they use D that's not 0 indexed. It's a real world value. And instead of trying to do D-1 every single time I want to put it into an array, which is 0 indexed, I will just put D directly and completely ignore the 0th index of this row. To get started, here's what we need. Here's edge case first. If we have too many days, then we cannot do a job for any certain day. It's not possible to give you an answer. Next, we're going to create the DP. Next, we're going to fill the DP with -1s. The reason to fill it with -1s is because the values can be 0. So we don't want to confuse a DP that hasn't been filled with a DP that has been filled if we have to fill it with a 0. Now we just do DFS. DFS is going to try every single combination of cuts. Zero, this value is the index that we're starting at. So we're going to check so we're going to try to cut it at 0 and then at 1 and then at 2, etc. Let's go ahead and write our DFS. Usually for your future problems, if you're using some sort of a dynamic programming like this one, most of the time your DFS is gonna return the value, and you're just gonna want to straight up return that DFS value. So so base case, if our D is 1, we just return the maximum of whatever is left in the subarray. So if we have made a cut here, then we don't need to look, and we'll have D left, D as 1. Then we know that we don't have any cuts left to do because making another cut will create 2 more subarrays, and we only want 1 subarray left. So all this line does is finds the maximum value of the remainder subarray and returns it. That's going to be, the result of our last part. That's the base class. Now we'll check if we are solving these parameters for the second time or more than second time. Okay. So if the value has been changed in the past, it's no longer -1. We're just going to return whatever we had gotten last time. Now we're going to do the actual meat of the core, the core of the DFS. What we need to do is here's what we're going to do for this example. This is what we're given at the very beginning, and d equals 2, right? It enters DFS using these values. What I want to do is first, I'm gonna keep a max value that's gonna have a continuous max storage. I'm gonna put like 3, 4 here. I'm gonna start at the first item. My max obviously is gonna be 3, and I'm gonna see, hey, if I make the cut right here, what will be the result? The result will be whatever this value, whatever the max of the left side is, which is 3, plus whatever the max of the right side. At that point, d would be 1 when we're sending it in again. And we're like, okay, d is 1, let's just find the max of this, which would be 6. So result is going to become 3 plus 6. That would be the best if we cut it here. Then we're like, okay, what if we cut it here? Our max is going to increase to 4. We're going to cut it, and this is going to return 6. Result will be 10. What we're going to do is we're going to keep our variable result, and we're going to keep the minimum result possible. So after attempting to cut it here, when we attempt to cut it here, the result is going to be 10. The result is not going to change. It's going to be like, well, 9 was better, so I'm going to keep 9. Next, we're going to cut it here. Max is going to become 6. And this is going to return 5. Result will be 11. Result is not going to change. It's going to remain 9. Next, it's going to try to cut here. 5. The max is going to stay as 6, but the return will be 5. Okay. It'll be 10, the result, but the result is already 9, so it's not going to go up. Next, this cut, it's going to be 6 plus 3. That's 9. Good, not good enough to go down. Next, the cut is here. 6 plus 2, that's 8. Good enough to go down, etc. It's going to go down. Now, let me show you how to put that in code. What I'm doing is I'm about to start making a cut at IDX, and I'm going to try to make a cut at every single spot up to drop difficulty.length minus d plus 1. Minus d plus 1 is because if we have like 5, we don't want to make our first cut like way over here because we're not going to have enough room to make the rest of our cuts. Finally, our result is going to be the minimum result, so the best cut possible. Obviously, you know it's going to go down because it starts at max value. And it's going to be the best result of max, so our max so far for that current array, plus the DP of whatever's left. And whatever's left is just going to continue doing the same cycle. Sometimes it's extremely difficult to really get in and walk through the recursions in your head. Try not to do that. Try to trust your code and trust that it's actually going to do what you want it to do. Now let's double check for errors before we run. I don't know. Looks good. Excellent. Let me know if you have any questions.